In this video, we are going to talk about section 9.1 about the nature of hypothesis testing. Okay, so um, in inferential statistics, right, one of the things that we need to do is to make decisions or judgments about the value of a parameter. And in particular, what we're going to do it for is a population mean. So it doesn't have to be a population mean, right? In general, you can make hypothesis tests about values of other parameters as well. But we are going to talk about hypothesis testing for population means. Okay, so an example of that would be this first example here. It says, does the mean weight mu of all bags of pretzels packaged by a particular company differ from the advertised weight of 454 grams? Okay, so right when you when companies package food like this, if you look on the bags, right, of pretzels, it has a weight of the pretzels inside the bag. So that is the advertised weight, right, of the bag of pretzels. But usually the packaging of pretzels like that is or other food items is automated, right? It's done by machines, so it can vary. It's not a perfect process when you do something like that. So what you will do, if you work for a company that packages food, then you'll have some people there that do quality assurance. Actually, that's kind of what my dad has done for a big part of his career. And so, they will pull off things and test and make sure that uh, that everything's as it's supposed to be, right? That it's clean and the other things like, is the weight of the bag correct? Are they putting in too much or too few, right, pretzels into the bag? Okay, and so this is basically their target, right? They want to be 454 grams, right, each bag. And so they will take a sample of the bags as they come off the line and then check the weights of those. And then, based on that sample that they've taken, they want to know, is it true, right, that the population of all bags, right, the mean weight is 454 grams. Okay. Another example here is, has the mean age mu of all cars in use increased from the year 2000 mean of 9.0 years? So back in 2000, they did, maybe a large study about how old are the cars in use. And, like maybe car manufacturers would do this, or car retailers, or maybe the government would do that for things like controlling the air quality and other situations like that. So in 2000 they did this study and they concluded, okay, the mean age of the cars in use is 9 years. Okay, so then in now 2020, right? Then maybe they think that people that this mean has increased, right, from 2000. In other words, people are using on average, right, cars that are older than 9 years. Okay, so the average would increase because people are driving cars longer. Maybe the cars are more reliable, right, so you can drive them for longer. Maybe people for whatever reason are not buying new cars like they did in 2000. Okay. And so you would do a sample, take a random sample of cars, and then calculate that mean of the sample. And then based on that sample, you're going to make some decision about, is this true or not? Has the mean age increased from the 2000 mean of 9 years? Okay. So that's sort of the decisions we are talking about making. And so a commonly used method for making such decisions or judgments is to perform what's called a hypothesis test. So a hypothesis is just a statement that something is true. Okay, and when we do these hypothesis tests, they're they're going to involve two hypotheses generally, one called a null hypothesis and the other called the alternative hypothesis. Okay. Um, all right, so let's talk about those. So the null hypothesis is a hypothesis to be tested. Um, we're going to use the symbol H sub 0 or H naught or H0. You'll hear me probably refer to it in multiple different ways. So that symbol is used to represent the null hypothesis. In our class, in our textbook, right, the null hypothesis is always going to have this form, right? That the population mean, mu, is equal to some number, okay? So now that's not true for every book you look at. You'll see different forms of it in different books. So I'm not going to talk about the different things that you might encounter, but you just do need to be aware, right, that our book and many other books have this convention that the hypothesis is all the null hypothesis is always in this format. But when you go look at other books, and that might not be the case. Okay, it'll be a variation. Again, I don't want to go into details on that, but just be aware of that. So, for instance, right here is an example of a very specific null hypothesis that the population mean is equal to 454. All right, so this is how a specific one would look like. All right, so as an example, going back right to that example that we had about manufacturing of pretzels, right? It says, does the mean weight mu of all bags of pretzels packaged by a particular company differ from the advertised weight of 454 grams? Okay. So the current state of things is that the mean, right, is believed to be 454, right? And so that's the format that the null hypothesis would take, right? That the mean is 454. Okay. And so the null hypothesis, it's usually going to represent what is currently assumed to be true about the parameter in question, right? So, hey, this company, right, they are advertising that the mean is 454, right? And so that's what's currently believed to be true, right? Right? And so, maybe whoever is doing this particular study thinks, hey, maybe that's not the case, right? Maybe it's our manufacturing process is not working the way it used to, right? Because of who knows what mechanical wear or other things like that, and that in the manufacturing process, well, maybe that the mean is not 454 anymore. Maybe it's a little bit bigger or a little bit less. Okay. All right. The alternative hypothesis is a hypothesis to be considered as an alternative, right, to the null hypothesis. Maybe it's what you think, right, has happened to the population parameter or population mean. So we'll use the symbol H sub A, right, to represent, that should say alternative hypothesis here, so that's a typo. So make sure you cross that out, or actually I could do that. So that should not say null here, or that should say alternative. Okay, so going back to the pretzel example that we've been talking about, it says, does the mean weight mu of all bags of pretzels packaged by a particular company differ from the advertised weight of 454 grams? All right, so for whatever reason, maybe the people at this company, the quality control people, think, hey, something's off with our process, and we think that this is no longer the case, right? That 400, or somebody suspects, right, that this is no longer the case, or maybe they just want to investigate, is this no longer the case? So the alternative, right, to the mean being 454 would be that the mean is not equal to 454. And that kind of encompasses two things, right? That means the mean could be a little bit more than 454 or a little bit less than 454. Okay, so this would be the alternative hypothesis here. All right, there are three different types of alternative hypothesis. So in the problem, when they're talking about this, whatever research or experiment that they're doing, right, they may say that their primary concern is whether the population mean is different from or differs from a specified value. Okay, and again, another typo here. Sorry about that. All right, this should be not equals to. Okay. So the primary concern is, if the primary concern is whether the population mean is different from a specified value, then the alternative hypothesis has this form right here, right? It's not equal to a specific number, okay? Maybe when they're talking about what kind of stuff they're doing, right, this testing that they're doing, they might be concerned whether a population mean mu is less than a specified value, in which case, right, the alternative hypothesis is going to look like this, right, that the population mean is less than, right, some number here. And in the language of, you know, when you're working these problems, they'll use either differs from, less than, or this last one, right, when the primary concern is whether a population mean is greater than a specified value. So the alternative hypothesis will look like this, okay? So the null hypothesis is always going to be H0, that the mean is equal to a specific number in our book, okay, and in our class. But the alternative hypothesis is going to be one of these three things. And to figure out which one of these three things it's going to be, you would just have to read through the problem, right? And they're going to mention things like, is the mean different from this, or less than, or greater than? So those are the keywords that you would be looking for in the problem. So you could figure out which one of the alternative hypothesis, which one of the forms of the alternative hypothesis it's going to be, okay? All right, so we can have one-tailed or two-tailed hypothesis tests. Which type it is depends on the format of the alternative hypothesis. So, man, I keep making the same typo here. So if the alternative hypothesis is that the that the mean is not equal to, right, or differs from a particular value, that's called a two-tailed test, right? And it's called two-tailed because, well, if you're not equal to a number, right, then there's two possibilities that you could be bigger than the number or less than the number. All right. When you have an alternative hypothesis that is using the less than, right, that's called a left-tailed test. If you're using the greater than in your alternative hypothesis, that is called a right-tailed test. So a one-tailed test is a test that's either left-tailed or right-tailed. Okay. So again, the tailedness of a test depends on the form of the alternative hypothesis. All right, let's take a look at this example here. It says, determine, this is problem 916 from our book. So here we have an experiment that was set up by somebody. They're going to do some testing, right? And our job here is to determine the null hypothesis, the alternative hypothesis, and classify the test as two-tailed, left-tailed, or right-tailed, okay? All right, so it says, Gray seals are one of several types of earless seals. The length of time that a female gray seal nurses her pup is studied by S. Twiss et al. In the article Variation in Female Gray Seal. Reproductive performance correlates to proactive, reactive behavioral types. All right, it says the average lactation period of all earless seals is 23 days. Okay, a hypothesis test is to be performed to decide whether the mean lactation period of gray seals differs from 23 days. All right, so here, right, in this sentence right here, they talk about the null hypothesis, essentially what is believed, right, to be known about the lactation period of these earless seals, or the gray seals, is that the average lactation period is 23 days. So that is going to be your null hypothesis. Okay. So the null hypothesis is that the population mean is 23, right? And then here they say a hypothesis test is to be performed to decide whether the mean lactation period of gray seals differs from 23 days, right? So they use that word differs or is different from, right? So we know that the form of the alternative hypothesis is that the mean is not equal to 23, okay? All right, so again, right, our null hypothesis is that always going to have this form, that the mean is equal, right, to some number. And so then our alternative hypothesis, you're going to have to look through the language, right, of the description of the test, right, to look for those keywords. And here the keyword is differs from. So, right, our alternative hypothesis is going to be that the mean, the population mean, does not equal to 23. Once we know that it is the not equals version of the alternative hypothesis, right, that's a two-tailed test. It's the only one that's two-tailed. Okay. All right, that is it for this basics of hypothesis testing. We're going to do a couple more examples just like this one here, but we're going to separate that out into some other videos.